involves the arithmetic progression. So let's write down an example of an arithmetic progression. I'll just make something up arbitrarily here. 27. Now notice that these terms are separated by a value of 8. That's sometimes called the common difference. So we say CD, I'll call it CD is equal to 8, right? Because you can get from one term to the next by simply adding 8. All right, now we're given in this problem here that this polynomial, third degree polynomial, has three distinct positive roots. And I said distinct because if they were indistinct, we could perhaps have an arithmetic progression that were just constants, common difference of 0. So we don't want that. It's not interesting. So what we can do is arrange the roots in this order. That's exactly this order: r minus d, r, and r plus d. This would be r up here, right? This would be r minus d. This would be r plus d. So that gives you an idea. And anytime you can do this, you know you're going to get some nice cancellation due to the symmetry somewhere along the way. Now there's a result called Vieta's. I won't go through it, but here's what it states. This is not hard to see if you just write down x minus a times x minus b times x minus c and expand it out. But what Vieta says for the cubic case at least is that the product of the roots is minus the constant term, which is minus 1524, which would be plus 1524. And the sum of the roots is minus the coefficient of x squared, which would make it 36. Okay, and it's just because you have three minus signs in the expansion, and they end up showing up. So that's why you have the opposite signs in Vieta's formulas. Now, so we get to this statement right here, which is what I just essentially said. And this is a fairly quick problem from this stage. Again, we're trying to find the common difference, D. Okay, trying to find the common difference. And from here, real quickly, we get that r is equal to 12. That's very straightforward because the d's actually cancel. So you get 3r is equal to 36, or r is equal to 12. Now from here, I'm going to write this out. R minus d times r plus d is the difference of two squares. So I'm going to go ahead and write down 12 at the beginning. That would be this r right here. And then that's going to be times 12 squared minus d squared. And again, I'm just doing the difference of two squares on the fly here. Okay. Now, something that's super useful here, and this would be what I would call the kind of a computational holdup right here, is to note that 2 and 3 divide 1524. 2 is obvious, and the sum of the digits here is 12, which is divisible by 3. So we know that 6 divides, you'll find out that 12 divides, and you would eventually get that this is equal to 12 times 127. And that's something that's within the realm of a hand computation. It's a little bit of trouble, but in competitions, and this was a competition problem, I think, similar to an ARML problem, as you saw at the top of the video. But watch what happens here. We get something quite pleasing here. The 12s cancel due to the nice factoring here. So we get 12 minus d squared is equal to 127. Okay, and so that's equivalent to saying 144 minus 27, minus 127, excuse me, is equal to d squared. And we are talking about positive values here. This would have positive and negative solutions. But this difference right here is 17, so you would get 17 is equal to the square root of 17, I should say, is equal to d, which is our common difference. And that's the answer to the question, folks. This is the answer to the question. Now notice, if we wanted to, we could write down we now know the zeros of the polynomial. Those zeros would be, 12 minus root 17? And a lot of you may not have been anticipating a common difference of square root of 17, but then you would have 12 as your middle term. Then 12 plus root 17. Okay, and that's it, folks. So that gave us an immense amount. A cubic generally is difficult. You could have tried to factor this, the way we did it here, and it would have taken some time probably, but you could probably do it directly. But I do think the structure of having positive roots that are consecutive terms, the consecutive was important right here, in an arithmetic progression, gives us quite a bit of structure, makes the problem almost trivial. Otherwise, if I didn't give you that, I think you could eventually get there, but it's a lot of work here to factor 1524 and try to determine where everything goes, But maybe about the same amount of work. I say that it gives you more structure and it makes it easier to solve the problem, but maybe not, so anyway, D is equal to root 17 is the solution to the problem. Thank you for viewing.